for this one specifically, we're just going to write the equation for it. So when we have a negative in front, what struggle is real. When we have a negative in front, what is that? Yep. It's a reflection in the x-axis. What's our mapping? XY becomes what? And then the negative's just going to get put in front of. Now, if you don't know what to do and you're like, oh goodness, I don't know what's in front. Well, in front is just completely in front of the whole thing. But say you're stuck, you can do this. Negative y equals 6 over x squared plus 3, bless you, and put it on that side, right? And then you could move it over by multiplication. So you could multiply this one by -1, this one by -1. So it would be y equals negative 6 over x squared plus 3, like that. Or the negative could join the 6, or the negative could join the whole x squared plus 3. So actually work for all of them. Now y equals f of negative x is a reflection in the our mapping is going to be xy becomes negative x comma y. And all my x's up here are going to change. So we have y equals 6 over negative x squared plus 3. Wait a second. Y equals 6 over x squared plus 3. The exact same. What does we suspect about this equation? If it's the exact same when I reflect it in the y-axis. It's symmetrical about the y-axis. So when you flip one arm and flip another arm, they'll land on each other, right? This one happens to do like whoop-de-woo through it, and it just flips. Okay. We're going to look at this one. Given y equals square root x minus 2, what happens if we do this? So what are we going to get? Y equals what? Where's the negative go? In front. And what do I do when it's a negative x? You substitute it in for x. It's just function notation, right? So it's going to be y equals negative x minus 2. I'm just proving a point by putting it in brackets, because when you substitute, you put in brackets. However, the brackets do nothing in this situation. So we could write it as and remember, we should be able to check these, right? If they don't have an f in them, we should be able to check them, because we should be able to put 1 into y1, 1 into y2, and they should reflect properly. You can also check with your mapping. Okay, I want you to try example 10. Quickly. Now we're moving on to reflection, or stretches, not reflections. We are on. So when we have a reflection in the y-axis, what is actually negated? The x's, because they're here, they're here, if they're here, they're here, right? We're moving like this, so our x's are being negated. So we're going to get y equals negative x squared plus 1, which is actually just x squared plus 1. Once again, the graph stayed the same. The reason why, this graph has a vertex at 0, 1, it's symmetrical about the y-axis, right? So this arm is going to go onto that arm is going to go onto that arm. And here's going to be my invariant point, right? So the graph looks like it hasn't changed, but actually it has, but it is the same equation. And then a reflection in the x-axis, we're going to get this. It has to go in front. This is the one that gets done wrong all the time. So it has to go in front, correct, of the whole thing. If you're someone who's not going to do that, make sure you put the negative with the y and then move it over by multiplying. Then you won't make that oopsie. So if we started with a negative y equals x squared plus 1, and then I just multiply by negative 1, multiply by negative 1, I'll get y equals negative x squared minus 1. And you should be able to catch your error, because at the very least you should know if you're right or wrong. Because you should be able to put y1 into y1, 1 into y1, 1 into y2, and they should reflect properly. So either you know you're right and you're happy, or you at the very least know you're wrong and you're not sure how to fix it. But maybe you could doctor it around a bit until you figure out how to fix it. Right? There's only 2 terms there. Now we're going to flip over. So we dealt with reflections in the x, which actually affected the y's. We dealt with reflections in the y's, but actually affected the x's, correct? So about the x-axis or in the x-axis, it's actually affecting y's. Verticals, same thing. Last year we looked at vertical stretches, but probably not horizontal. So a stretch is a transformation that changes the size and the shape of the graph. The original and the new graph are not congruent. So it either stretches it wider or narrower, or taller or shorter. Right? Now there are 2 types of stretches, vertical or horizontal. Vertical is the taller and shorter, horizontal is the wider and narrower. The good thing is we don't have to say wider and narrower or taller or shorter anymore. We just say stretch. Okay? Vertical stretches are the ones that make it taller or shorter. Correct? Vertical. I'm making it taller or shorter. What am I moving? The x's or the y's when making it taller or shorter? The y's, right? So vertical stretches affect the what? The y's. It only makes sense to pull it higher or pull it or to squish it. I'm affecting my y's. So I'm either multiplying my y's by like 3 and making them higher, because 3 would go to 9 and negative 3 would go to negative 9, which would stretch it taller. Or I'm stretching it shorter by like multiplying it by like a half or a fraction between 0 and 1. We agree? Okay. So vertical stretches are in the form y equals a f of x, where a stretches the graph vertically by a factor of a. The point xy becomes xay. So if I do my mapping, it's xy becomes xay, because stretches and reflections have to come first before transformations. Transformations we add or subtract to get to the thing, correct? But stretches and reflections we multiply. That's why I told you they had to come first, because of order of operations. So stretches and reflections will always multiply. The points on the x-axis are invariant. Once again, the x-axis are invariant because the points on the x-axis are always of x and a 0. Well, if I'm multiplying 0 by any number, it's going to stay 0, correct? So that's why reflections on the x and stretches will remain invariant for x-intercepts. If a has a negative sign in front of it, it's a reflection in the x-axis. It's not a stretch. So if it's like negative 7, you don't say vertically stretch by a factor of negative 7. The negative doesn't stretch it at all. The negative reflects it, correct? So you'd say vertically stretched by a factor of 7 about the x-axis, and then you'd say reflection in the x-axis, because the negative makes you have another statement. It doesn't actually, you can never ever say a stretch is negative, because it's not. That's a reflection. Okay? So here we're going to describe the transformations that have occurred. We always go stretch, reflect, then translate. The original graph, so we will describe the transformations that occurred if the original graph of y equals negative 4 f of x was this. This is the original. It has nothing on it. That should make you happy, because then that means that's all transformations over there. Also, this one has an f in it, correct? So this is just another fancy way of describing the transformations without using words, right? They're just giving it to you in a transformation equation. Okay? So we know that we should start with stretches first. If there's a number sitting in front, we have a vertical stretch. The only time we have a translation is if we had a number sitting at the back, the +6. Remember, we learned that already. So this is a vertical stretch, and it has to be stated this way, so you might as well start getting used to it and not short forming it. It has to be exactly this way. Vertical stretch by a factor of 4. About the what axis, do you think? When this reflection happened, what axis was it in? In It affects the y, so it's in the x. So whenever it affects the y, it's actually in the x. Same thing as vertical. So this is vertical stretch by a factor of 4 about the x-axis. It makes sense if you're writing vertical stretch for it to be about the x-axis. Let's think about it. If the graph has a point down here and the graph has a point up here, we agree? Say it's a 3 and a negative 3. This one's going to go to, say it's a factor of 2. This one's going to go to 6. This one's going to go to negative 6. Where are we stretching it about? Which axis is located between my two arms? The x-axis. That's why it's about the x. It's a reflection in the x, it's about the x. So whenever it affects the y's in mapping, it's about the x. There's a vertical stretch by a factor of 4 about the x-axis, and then we have a reflection in the x-axis. It's always about the opposite axis of what you think. So verticals are always with the x-axis, horizontals are always with the y. So here we are given the graph of y equals f of x. Use a table of values to sketch y equals 2f of x. So we're moving a graph. What are we going to use? Mapping. So our xy is going to become what? X. X stays the same. There's nothing happening to it. 2y. So negative 2, 0 is going to become negative 2 and then 2 times 0. So it's going to stay negative 2, 0, right? And negative 1, 2 is going to be negative 1, and then 2 times 2, which is 4. 0 and 5 is going to become 0 and 2 times 5, which is 10. And then 4 and 0 is going to become 4 and 2 times 0, which is 4. That's an aggressively large box. 4 and 0. Oops. Didn't really space that out properly. So now we draw our new points. We have negative 2, 0. We have negative 1, 4. We have 0 and 10. And 4 and 0. The two x-intercepts are invariant, right? They didn't change. This is not. Make sure to use a ruler when you do this. Mine's just eyeball. Could I pick more points and move them? Does it just have to be the bolded points? No, if I wanted this to be more accurate, I could kind of pick other little points along the way to try and maybe decimally, but try them out. All right. Flip over when you're done. Here we have the graph of y equals x squared. Graph the y equals x squared. So that's going to be at 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. X scale 1, y scale 1. Try and draw that straighter than me. My left, this part of the board is all, it doesn't draw usually where I want it to. So we graphed it, and then we replace y with 3y. So we go to the y in the equation y equals x squared, we grab it, we throw it behind our heads, and we replace it with 3y, right? So I have y equals x squared. I rip this y off the page, I throw it away, and I replace it with 3y. Then I want to get into y equals, so how do I move the 3? Divide by 3. And dividing by 3 is the same as multiplying by what? Because this isn't as helpful to me in that format. Dividing by 3 is like multiplying by a third. Now it's sitting in front and it's actually a vertical stretch, right? So what is happening with this one? It's a vertical stretch by a factor of what? about the x. And my mapping would be x, y becomes x, comma, 1/3 y. So technically, all my x's are staying the same, but my y's are being thirded. If thirding is the thing. Made it like an action verb, thirding. Okay, so we have -1 and 4 is going to become -1 and 4/3. We agree? So it's -1 and like, that's not -1, that's -2. Oops. -2 and 1.33333. So it's going to be like here. Then we have -1 and 1 is going to become -1 and 1/3, because 1/3 times 1. So -1 and 1/3 here. And we have 0, 0 is going to become 0, and 0 times 1/3. Whoa, it stays the same. It's invariant. And this one's going to be 1/3. Oops. And 1 and 1/3, because it's symmetrical. Okay, I want you to type square root of x into your calculator. We're going to know it greatly, just not at this very moment. We do a whole unit on radicals. We did radicals last year, but we didn't do a lot of radical graphs. We did like a lot of radical operations, like conjugating the num, multiplying by the conjugate. Okay, so when you put root x in and you press graph, there's like no negative x's. Does that make sense? Yes, because in grade 10 you're taught t-tables. Actually in grade 9 and 8 you're taught t-tables. Where you put an input, you get an output. You put an input, you get an output. Correct? So if I put an input in for x here, I go square root -1. Is that real? Does that exist? I put -2? No. What's the first number that I can put in here that'll work? 0. Square root of 0 is? 0. So hence why you're seeing on your screen in front of you that it's starting at 0, 0. We agree? The next x I put in as a 1. What's the square root of 1? 1. So we get 1, 1. Now you can put in 2 and you can put in 3, but the next one I put in, if I have a choice, is 4. And the reason why I put in 4, bless you, is because it gives you an even number. Square root of 4 is 2, right? So then I get 4, 2. And then the next one I do is 9. 5, 6, 7, 8, 9, 3. And I should be labeling all my graphs, and I should be labeling my scales. So this is y scale of 1. This is x scale of 1. Now it says graph y equals square root x, and replace y with a half. Okay, so we're going to get 1/2 y equals root x. How do I get a half to move over? Multiply by 2. Now, could I not just type that in and then graph it that way? Yes, but if I have the parent function, can I not just use mapping? Yeah. So you can go x, y becomes x, stays the same. There's nothing happening to it, and I'm getting a 2y. So my 0, 0 is going to become 0, comma 2 times 0, which is just 0, 0. And then I have 1, 1. It's going to become 1 and 2 times 1, which is just 1 and 2. And then 4, 2 is going to become 4 and 2 times 2, which is 4, 4. And then the other one is going to go off. So something like that. So it seems like it's making it taller, right? Stretching it vertically. Next, we're doing horizontal. So remember, horizontal translations were the opposite. If I had x minus 3, I actually moved 3 to the right. If I had x plus 3, I moved 3 to the left. They were opposite. Horizontal stretches flip every single time. So some people are like, when do they flip? Every single time. Then they'll bring it over to me, do they flip here? I'm like, they flip every single time. Then they'll bring it over and be like, do they flip here? And I'm like, every single time. They're like, when do they not flip? I'm like, never. They flip every single time. So if we can walk away knowing that from the equation to the words, the horizontal stretch flips every single time, you will be in a much better boat than most people. Okay? So what the heck does that mean? Well, my vertical stretch, this 2 in front, said I had a vertical stretch by a factor of 2 about the x-axis. Do you agree? Nothing flipped. Nothing changed. Horizontal stretches actually flip. So here it says horizontal stretches are in this form, where b stretches the graph by a factor of 1 over b. Whatever this is, so it's b over 1 now, it actually stretches it by 1 over b. It's the reciprocal of it. So if I had a 2/3 in front, it would stretch it by 3/2 every single time. So remember, from the equation to words, it flips. From words to the equation, it flips. In mapping, from words to mapping, does it flip? Words and mapping are in the heart. We agree? Words and mapping, they're in the heart. They mean the same thing. So they're not going to flip. If in words I have 1 over b, in mapping I'm going to have 1 over b. Words and mapping in the same heart. So if words and mapping are in the same heart, then from equation to words it's going to flip. From equation to mapping it's going to flip. But words to mapping it doesn't. Right? So equation to mapping, it flips. Equation to words, it flips. But words and mapping are the same, so it does not flip. So that's where people get mixed up, right? You can see how that could happen. In words and mapping, I keep whatever number I have. If they give me words and I need mapping, same number. Mapping, I need words, same number. Because in words and mapping, they're just the same way. It's just like you came up to me and said, Mrs. Lepp, I don't understand that in words. And I'd be like, oh, well, here's another exact same way in mapping that you can have. Okay? All right. So the point xy becomes x over by, which is confusing to people. Or you could say xy becomes 1 over bx, comma y. So it's the same thing as vertical stretch. The number just sits in front. They just happen to be like, hey, I can write it as x over b. It's the same thing. Points on the y-axis are invariant because now you're multiplying by all the x's, and y-axis points have a x of 0. And the b sign makes it have a reflection in the y-axis. There is never a horizontal stretch that is negative because the stretch doesn't be negative. That's a reflection. So we're back to the same boat here. Describe the transformations that occurred from this graph. So when we have y equals f of x, and it was y equals 5 f of 5x, I'm struggling, and it was y equals f of x. So we have this 5 sitting by the x. So because it's sitting in front, we know it's a horizontal stretch. That is a fact of all facts, and most people are really good at that. Okay? It's a horizontal translation, it's a horizontal stretch. Great things happen there. What we need to remember every single time is if I'm going from an equation to words, or I'm going from equation to mapping, it always flips. The mapping and words stay the same, correct? So we're going to see that. So we're going to say we have a horizontal stretch by a factor of what? 1/5. About the what axis? About the y. It's always the opposite, right? So if it's with the x, it's always about the y, because in order for it to stretch it horizontally, pulling it this way, squishing it, it's about the, I feel like I'm a sideways shark, but it's about the y-axis, yeah? And then mapping, x, y becomes, it's going to affect my x because it's with my x. Mapping and words are the same number. So I have 1/5 in words. I have 1/5 in mapping. 1/5 in words, 1/5 in mapping. Mapping and words are the same. What number I have in words, I have in mapping. What number I have in mapping, I have in words. The only time it flips is when equation to words, words to equation, equation to mapping, mapping to equation. But mapping and words, always the same in a heart, a visualized. So here we have this. Y equals f of x, sketch the graph of y equals f of 2x. So what's my mapping going to be here? X, y becomes what? X over 2y or 1/2 x. Either way, and y, same thing, right? You can do it like this, or you can do it x over 2. It's the same thing. But it's flipping because I'm going from equation to mapping. So equation to mapping, equation to words. The only time equation doesn't flip is if it's equation to wait, that doesn't happen. It's an equation, right? So equation to words, it flips. Equation to mapping, it flips. The only time it doesn't flip is words and mapping. Words and mapping. They are friends. They're friends in a heart. I draw it on every test that I ever do. And I see it on lots of tests too. Words and mapping in a heart. Nothing changes. Okay? So we have negative 2, 0. It's going to become 1/2 times negative 2, comma 0. So it's going to become negative 1, 0. Then we have negative 1, 2. 1/2 of negative 1, comma 2. Half of negative 1 is just negative 1/2 and 2. So we're going to graph negative 0.5 and 2. Then we have 0 and 5. It's going to become 1/2 of 0 and 5, which is 0, 5. And then we have 4, 0, which is 1/2 of 4 and 0, which is 2, 0. So we have negative 1, 0. Negative 1/2, 2. This stays. 2, 0. The graph narrowed, making sense. I'm halving all the x's, right? I'm squishing it. So actually, if your b value in your equations, if this value is like 1/3, the graph's going to get wider. Because 1/3 in front of the x is actually a horizontal stretch by a factor of 3, right? So it makes it wider because it was flipped. Okay, then we're going to flip over. We are flipping. I know there's another thing. We're just going to run out of time. That's how the computer died and did some weird things. Okay. We're going to go here. Example 5. Describe the transformations that occurred when y equals 4 minus x cubed is transformed into these. So this is the original. See that? The number is sitting in front, which means it could have been 1/3 over here, correct? So we know it's a vertical stretch because I can multiply it over here and make it a 3. We agree? Did anything happen to this? Or was that already always there? That was already always there. Some people are telling me reflections, translations. No, that was there. That's from there to there. That nothing has occurred between those two, right? So we know that this is a vertical stretch. By a factor of what? Of 3. About the opposite axis. So it's about the x because it's affecting the y's, right? Verticals never switch. If you move it into y equals, your vertical numbers will stay the same. You'll move up or you'll move down. If it's positive or negative, you'll stretch by whatever the number is. Mapping, what is this? X, y becomes no change in x. What happens to my y? 3y. Mapping words, same numbers. Now what happens on B? What do we have happening here? The 4 is the same, the minus sign is the same, the 2x is the change. It's with the x, so it's a what kind of stretch? Horizontal. It's a horizontal stretch by a factor of? About what axis? I use 1/2 in words, I use 1/2 in mapping. So I'm going to get xy becomes 1/2 x, y. I use the words, I use the mapping. Same number, right? Do you see how every single time it's the same number? Okay? These are when they're combined, but we're doing that on Monday. We're not doing the combined ones. So your homework is on Monday we put them all together. So we put translations together, reflections together, stretches together. Okay? Page 29. 5 to 7. And 9. So I'm going to start, I posted the assignment that I have for terms and comms. It's already posted. I gave you till Sunday at midnight. Okay? I'm going to post a new one for these, but I don't expect it handed in until we're done. So my due date is going to be wonky. Don't go based off of it. I'm just going to put a guesstimate as to what my due date is. But it's going to be probably Friday of next week. But I'm just going to start adding the assignments as you go along. So what you can do, if I were you, as you do your homework, I would just take, you can do a scanning app, right, like Adobe Scan, and you can literally just take pictures of it and keep it in one document, and then post that document when it's due. So you don't have to take pictures the whole time. You just take pictures as you go along, boom, 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 keep it in one document, and then post it to my classroom when it's